If life were to exist on another planet in the universe, where do you think it would be? Scientists have been grappling with this question for centuries. However, the scientists of today have better tools at their disposal, and the most powerful one is the new James Webb Space Telescope. This mighty space observatory has already locked on a target and is delivering promising results in the search for life. One of the signs of intelligent alien life picked up by the JWST is artificial light, and it's examining Proxima b. What exactly has this telescope found on Proxima b? Why is it looking specifically for artificial lights on the planet? And should you be preparing for a visit by aliens from outer space? Keep watching as we bring you James Webb Space Telescope's new artificial lights discovery on Proxima b. Scientists have been building telescopes for years, but none has come near the new James Webb Space Telescope. In fact, it is 100 times more powerful than the Hubble Space Telescope, which has been sending back stunning images of deep space for 3 decades. The JWST is so sensitive to infrared light that it can detect even the slight heat of a bumblebee at the distance of the moon. NASA said it could also see details as small as a US penny at a distance of about 25 miles. Of course, NASA is not launching a $10 billion space telescope to search for bumblebees or pennies. The project is meant to paint a clearer picture of how the galaxies formed and potentially answer some long-standing questions about the early universe. The Hubble is iconic for producing mesmerizing photos of space, but it has a limitation. It can't allow scientists to see the very first galaxies that formed after the Big Bang, and this is what the JWST is going to change. In this regard, you can say NASA has put a huge time machine in space. Scientists will be able to sample light that has been traveling across the cosmos for as long as 13.5 billion years, several hundreds of millions of years more than the Hubble. One of the most iconic parts of the JWST is the sun shield that allows it to stay cool. This cooling is necessary for the telescope to function as intended. The shield is as large as the size of a standard tennis court and had to be folded to go into the launch vehicle. The side facing the sun will experience temperatures of about 260 degrees Fahrenheit, while the other side will be chilled to some 370 degrees below zero, a nearly 600-degree difference. But the focal point of the JWST is the primary mirror, divided into 18 segments and covered in a gold coating so thin that a single strand of your hair is 1,000 times thicker. This mirror had to be folded too for the launch. One interesting or scary fact, depending on how you view it, is that the JWST is literally beyond repair. It's so far away that it's not practical to send a crew in for a repair. It can't even be refueled as of now. This is unlike the Hubble, which has been visited multiple times for repairs and parts changes. But of course, the Hubble is only 314 miles away, while the newer telescope is located 1 million miles away. So the JWST mission ends the first serious problem with the telescope, a $10 billion gamble, huh? Meanwhile, the JWST is not going to dwell on the past only. Thanks to its sophisticated parts, this mighty telescope will help scientists study exoplanets, or planets outside the solar system. Prior to the launch of the JWST, exoplanets were very difficult to even detect, not to talk of studying. Scientists are especially interested in one exoplanet but had to wait for the JWST to be able to study it in detail. Before we go into which exoplanet scientists badly want to study and why they want to study it, why are exoplanets so difficult to detect and study? The first reason is that they are so far away. The closest stars outside our solar system are so far away that we can't send astronauts there, barring any huge breakthrough in space travel. The second reason is that these exoplanets orbit stars whose brightness makes it hard to see the orbiting planets. It's like trying to observe from a distance an object placed in front of a bright light. So scientists had to devise other methods like the transit method, which observes how the light from a star dims temporarily as a planet passes across it during its orbit. The Kepler Space Telescope uses this method to detect exoplanets, and scientists can use the data to determine the size and orbital periods of the planets. In fact, the majority of exoplanets discovered were found using this method. However, with the launch of the JWST, the job of exoplanet hunters will become easier. And one of the exoplanets the scientists are eager to study is Proxima b. What is special about Proxima b? The most exciting thing about Proxima b is how much it looks like our planet Earth. This exoplanet, which lies just 4.2 light-years from Earth, is just 17% more massive than our planet. Using a shell spectrograph for rocky exoplanet and stable spectroscopic observations, or ESPRESSO, a team of researchers has unearthed some facts that strongly suggest there are signs of life on Proxima b. ESPRESSO is a Swiss spectrograph that is currently mounted on the European Southern Observatory's ESO Very Large Telescope in Chile. Spectrographs observe objects and split the light coming from those objects into the wavelengths that make it up, so that researchers can study the object in closer detail. Proxima is a relatively newly discovered planet, as scientists discovered them in 2016. Thanks to ESPRESSO, scientists have determined the mass of the planet with a precision of over 1/10 of the mass of Earth. More interesting is Proxima b's location relative to the star it orbits, the Proxima Centauri, which is the closest star to us. It occupies the Goldilocks zone, or the path around its star that allows it to be habitable. This means there is the possibility of the existence of liquid water because of the temperature. Water is one of the requirements for life as we know it. Proxima b orbits its star completely in just 11.2 days, unlike the Earth, which takes much longer. This is because it's closer to its star than the Earth is to the Sun. But because the star, Proxima Centauri, is much less powerful than the Sun, it is a red dwarf, the exoplanet is still able to remain in the habitable zone. In fact, Proxima b receives about the same energy from its star as what the Earth gets from the Sun. Proxima b is tidally locked to Proxima Centauri, meaning one side of the planet is permanently facing the star, hence a permanently dark and a permanently bright side. The Earth and Moon are in the same cosmic relationship. One of the things scientists will use the JWST to confirm is whether Proxima b has an atmosphere. An atmosphere may be required to protect the exoplanet from possible radiation coming from Proxima Centauri. The atmosphere will also allow Proxima b to hold on to its water if it contains some. There is another sign of life on Proxima b that scientists are hoping to study. The JWST will help tremendously here. In fact, this is one of the surest signs of alien life on an exoplanet. The idea came from the fact that Proxima b, as we said earlier, is tidally locked to its star. Because one side of the exoplanet is always dark, a Harvard astronomer R.V. Loeb has postulated that aliens as advanced as us could be using artificial lights to illuminate their surroundings, just as you would turn on a light switch when it gets dark. These artificial lights could be gotten through powerful mirrors or very bright LED-style lights. All we need to do is to capture these bright lights, and we can confirm there are aliens on the exoplanet. And this is where the JWST comes in. But is it really possible that aliens will choose to stay or be active in the dark parts of Proxima b? Well, Chinese scientists recently pulled off a landing on the permanently dark side of the Moon. Who knows what the aliens on Proxima b are doing in the darkness of their home planet? Loeb suggests that using the near-infrared instrument on the JWST telescope and looking for the telltale signs of LED light waves in the light from the planet and its host star, we can detect this artificial light if it exists on the exoplanet. Loeb sure knows his onions. The professor has spent more than a decade predicting the existence of aliens, suggesting how they can be discovered. He is part of the Breakthrough Starshot project, seeking to send laser-boosted light sails on a trip to Proxima Centauri at high speeds, reaching this star in decades. The astronomer also wrote a paper claiming the interstellar asteroid Oumuamua was humanity's first contact with an artifact of extraterrestrial intelligence. He has now turned his attention to Proxima b, which, for many alien hunters, is a prime candidate in the hunt for signs of intelligent alien life outside the solar system, and he is banking on the JWST to get all the data needed to validate his theories. Loeb said his team considered different scenarios, including artificial illumination with the same spectrum as commonly used LEDs on Earth, and a narrower spectrum that leads to the same proportion of light as the total artificial illumination on Earth. They realized that the JWST can detect LED-type artificial lights, making up 5% of stellar power. This theory of artificial light requires optimal performance from the near-infrared spectrograph or NIRSPEC instrument on the JWST. To come to the conclusion that it may be able to detect artificial light, Loeb and colleagues used the JWST Exposure Time Calculator. This is a tool that allows astronomers to predict what can be detected in any given time period based on predefined settings before the observatory launches. It allowed them to determine the likelihood of detecting different flux values and detecting those with a wavelength that matches artificial light levels that should be expected from a civilization living in permanent darkness on Proxima b. Let's hear what you think of aliens inhabiting Proxima b in the comments section below.